All right, so we're going to simplify radicals with radicands containing variables, and we're going to assume that the variables represent positive numbers. So we're going to simplify each of the following. So let's talk about this one first. The square root of x to the 8th. See, that has a variable in it. Well, think about what we did previously. So the square root of x to the 8th means this. Listen carefully. What times itself is x to the 8th? Okay? So you got to remember some things that you learned in the previous course. So for example, do y'all agree that x to the 4th times x to the 4th is x to the 8th? Because remember, one of the properties you've learned in a previous course, the product rule for exponents. So when you multiply like bases, you add exponents. 4 plus 4 is 8. So the square root of x to the 8th is x to the 4th. But I want you to think about it this way as well. See that index is 2, right? The index is 2. Many students, now you really have to think about it like this as well, but many students also think about it this way. 8 divided by 2 is 4. 8 divided by 2 is 4. So the square root of x to the 8th is just x to the 4th. So using that idea with number 2, let's look at number 2. Let's suppose we had the square root of x to the 10th. Well, in our mind, you can think of it this way. What times itself is x to the 10th? Well, x to the 5th times x to the 5th is x to the 10th. Because when you multiply like bases, you add exponents. 5 plus 5 is 10. But you also know that based on what we just did, I could say 10 divided by the index, 2. 10 divided by 2 is 5. So I get x to the 5th. Okay? So we're going to use that idea. So in number 3, we have the cube root of x to the 24th. Cube root of x to the 24th. Without having to think about, well, what times itself 3 times is x to the 24th, I want you to think about what we did here. X divided by 2 is 4. 10 divided by 2 is 5. 24 divided by 3 is 8. So this is x to the 8th. And now it kind of makes sense because x to the 8th times x to the 8th times x to the 8th. When you multiply like bases, you add exponents. 8 plus 8 plus 8 is 24. All right, number 4, we have the square root of x to the 6th times the square root of y to the 10th. So don't let the fact that there are 2 different variables in the radicand. I can write this using the product rule for radicals. I can write this as the product of 2 separate square roots. So in other words, I can write this as the square root of x to the 6th times the square root of y to the 10th. So according to the product rule for radicals, so you can rewrite a square root of a product as the product of each square root. And now, if you need to cover up, let's say this one. So the square root of x to the 6th, 6 divided by 2 is 3. So that's x cubed, right? And then the square root of y to the 10th, 10 divided by 2 is 5. So that's y to the 5th. So there's your answer. X cubed, y to the 5th. Kind of makes sense because think about it. If you want to think about it, x cubed times x cubed is x to the 6th. Y to the 5th times y to the 5th is y to the 10th, which is what we had here. Okay? All right, number 5. Now, for us right now, I'm just saying this, for us right now, you see how easy this is? That's this week. Next week, it won't be that easy. You see how 8 is divisible by 2? 24 is divisible by 3? Next week, it won't be that easy, but everyone can do it without any difficulty. See, next week, this is going to be a 9. 9 is not divisible by 2, so you're going to ask yourself, well, how do I deal with that? Well, you'll see next week. It's fairly easy. But for this one, it's so easy for this week because the problems you have here, the exponent will be divisible by the index. So look at number 5. Number 5, we have the cube root of x to the 9th, y to the 21st. All right, if you need to, break it apart. You don't have to do this step. You can go from here to the answer. And that's what most students do. Most students will go from here to the answer with these. 9 divided by 3 is 3. 21 divided by 3 is 7. Okay? But that's really what's happening. You're really using a product rule. So you're saying the cube root of x to the 9th times the cube root of y to the 21st. So 9 divided by 3 is 3, so that's x cubed. 21 divided by 3 is 7, so that's y to the 7th. And there's your answer. Okay, very simple. Not difficult at all. Number 6, but again, remember, this week is easy. The exponent will be divisible by the index. Next week, it won't be this easy. It's still going to be easy, but not as easy. Next week, you have something like 11 here. 11 is not divisible by 3. So what do? You'll learn that next week. Number 6. Okay, number 6. Let's think about number 6 this way. So I'm going to write it like this, x minus 8 squared. Okay, the way I want you to think about it is this way. See how this is a binomial? So ask yourself, what times itself is x minus 8 squared? Well, x minus 8, right? X minus 8 times x minus 8 is x minus 8 squared. So same thing. 2 divided by 2 is 1, right? 2 divided by 2 is 1. So this is x minus 8 to the first, which is just x minus 8. So there's your answer, x minus 8. Okay, number 7. Number 7, suppose we had this in number 7. Okay, number 7, we have, okay, number 7, we have the square root of 8x squared, right? So if you let's think about it this way. What times itself is 8x squared? Well, 8x. 8x times 8x is 8x squared. But I can also think of it this way. 2 divided by 2 is 1. So that's 8x to the first, but 8x to the first is just 8x. So write your answer as 8x. Number 8, we have the square root of 49, x to the 10th. Now this time you have a coefficient there. So I'm going to use a product rule. So let's look at what I'm doing. Now remember, this week is easy. These are going to be easy expressions. Next week it won't be as easy. But you'll be able to do it. It just won't be as easy. This week is easy. So I'm going to use the product rule here. According to the product rule, that's the square root of 49 times the square root of x to the 10th. 49 is a perfect square. Square root of 49 you know is 7, right? This is easy because 10 is divisible by 2. 10 divided by 2 is 5, so that's x to the 5th. So there's your answer, 7x to the 5th. So the square root of 49 is 7. The square root of x to the 10th is x to the 5th. Number 9, you have the cube root of negative 27, x to the 27th, y to the 3rd. Don't let the fact that you have 3 things here throw you off, the fact that this is negative. Write it out using a product rule if you need to. Cube root of negative 27, cube root of x to the 27th, times the cube root of y cubed, and then simplify each one. We already talked about this. The cube root of negative 27 is a negative 3. The cube root of x to the 27th, 27 divided by 3 is 9. So that's x to the 9th. Cube root of y cubed, 3 divided by 3 is 1, so that's just y. So there's your answer. Negative 3x to the 9th, y. Number 10, you have the square root of 100, x to the 6th, divided by 9y to the 9th. Okay? Now this, we're going to use the quotient rule now. See, when you have division, that's a quotient rule. Quotient rule, division. Division. So I'm going to break this, I'm going to write this as the square root of 100, x to the 6th, divided by the square root of 9y to the 9th. Oh, I'm sorry, I can't use a 9 here. Let's use 8. Let's make that 8. Sorry, 8. Make that 8. Okay, y'all see why I changed it? Because 9 is not divisible by 2, so that has to be next week. So for this week, I got to make it easy. Okay, well, you all know the square root of 100 is, what's the square root of 100? 10. What's the square root of x to the 6? 6 divided by 2 is 3, so that's x cubed. The denominator, the square root of 9 is 3, and 8 divided by 2 is 4, so that's y to the 4th. And there's your answer. You're done. Square root of 100 is 10. The square root of x to the 6 is x cubed. The square root of 9 is 3. And the square root of y to the 8th, 8 divided by 2 is 4. All right, 11. The fourth root of 81, a to the 20th, b to the 32nd. All right, now at this point, you don't have to keep using those rules. Most students can say, all right, the fourth root of 81 is 3, because 3 times 3 times 3 times 3 is 81. So that's 3. 20 divided by 4 is 5. So the fourth root of a to the 20th is a to the 5th. 32 divided by 4 is 8. So the fourth root of b to the 32nd is b to the 8th. And there's your answer. And then finally, number 12. Let's do one more, and then we'll stop. Number 12, we have negative square root of 625, x to the 4th, y to the 2nd, z to the 14th. Okay? And I'm going to go ahead and again, you can go from here to the answer, and that's what most students will do. Go from here to the answer. But I'm going to break it apart. So I'm going to say negative square root of 625 times, I'm using a product rule, times the square root of x to the 4th, times the square root of y squared, times the square root of z to the 14th. This one is a little bit more difficult for students. They have a difficult time figuring out, well, what is the square root of 625? Well, use a calculator. Square root of 625, right? So square root button is, you got to say second square root like this. 625, press equal, 25. So the square root of 625 is 25. 25 times 25 is 625. So this becomes negative 25. 4 divided by 2 is 2. So that's x squared. The square root of x to the 4th is x squared. 2 divided by 2 is 1. So that's square root of y squared is y. And then 14 divided by 2 is 7. So that's z to the 7th. And that's it. So that is, now remember, this is the easy kind because all of those exponents were divisible by the index. Next week it will be. But you understand, you will figure out what to do next week when we do this. So this was the part on one of the worksheets where you are going to have to simplify the radicals with radicands containing variables. But those are going to be the easy kind for this week. Okay? All right, so we are past our time limit. So let me go ahead and end this.